There we go. All right, we're back on. Okay, guys, we have had about a bazillion interruptions so far when trying to do these streams. And what time is it now? Like 7 or something? I have like an hour to get through 3 topics here, which is brilliant for day 1 of these. We have 20 days, remember, guys, 20 days until exams. So I'm trying to fit as many topics in as quickly as possible. I want these streams to be as fast-paced. So, number 1, we're going to do history, first of all. History. And we're going to be looking at the end of a Cold War, because that's what I've done today. Anything that I do in lessons, I'm going to translate to you guys. So if you're not in my lessons, or you're a set below me, something like that, maybe these lessons might not be as helpful, but I'm just trying to convey information that I've learned while also helping myself. Because remember, it's my revision as much as it is yours. So, number 1 is history, end of a Cold War. We need to write a narrative account analysing the key events of a Prague Spring. And the 3 stimulus points, well, the 2 stimulus points. Number 1, Alexander Debek, I'm just going to pronounce it like that, Soviet control. You must also use information of your own. So, I've wrote here that this is a 3-paragraph question and it's worth 8 marks, which is, I don't know how many, maybe it's 52 in the exam. Remember, this is Elizabethan as well, so you're going to have to balance out your knowledge of Elizabethan England with Cold War. So you're going to be talking about bloody Francis Drake and his raid and things like that, and then you're going to immediately contrast that with bloody talking about ballistic missiles and nukes. So anyways, the point that I've added is fears the Soviets had about a Prague Spring. Because if you remember, the Soviets were worried that this new liberal sense of thinking that Debek introduced, they were worried that it would influence other members of a Warsaw Pact and it would make them want to leave Soviet control. And as a result, Brezhnev obviously attacked. He sent in, I think it was 500,000 troops, and they wiped the floor. Debek did want everyone to fight peacefully, to protest peacefully, so there wasn't much violence, but I believe that Debek was arrested in the end and replaced with a hardline communist leader. Now I've chosen to do this middle bit here. I've chosen to add my stimulus point here, right in the middle. Thing about a narrative account is you want to make sure it's in chronological order. So we have Alexander Debek. So what do we talk about with this bloke? Well, you firstly want to talk about the context to him. So the context for his introduction is that there was a hardline communist leader. There was a hardline communist, and because Czechoslovakia at the time was in an economical down, it had financial issues. A consequence of those financial issues was that there were protests, unrest. And where were those protests and unrests directed towards? They were directed towards the hardline communists, aka communism as a whole. So it was quite a tough time. So as a result, he was appointed in order to try and make people, support communism, to try and undo the mistakes. So what he introduced was socialism with a human face. But what that basically meant was liberal changes. He wanted to have more liberal changes, things like trade unions, more political parties. So basically, this is a repeat of the Hungarian uprising. Relatively similar, I would say. Of course, they kind of... The thing is, they both started kind of the same, with a leader, hardline leader getting replaced with someone more liberal. But then in the end, the exact opposite happens. So that's what I would talk about in paragraph 1, his liberal changes. That's what I would talk about in paragraph 1. Now I have chosen to talk about the fears because I believe Soviet control here refers to them actually just controlling it, like the aftermath. I don't know whether that refers to them taking control or the aftermath. Maybe it's kind of ambiguous on purpose. I guess it's meant to be, isn't it? Where is my cleaning cloth, actually? I don't know where it really is. But one thing I use, and I don't know where it is. Let me see if I can quickly find it. If not, I'm just going to have to bloody use a green screen or something. I don't use this thing anyways. Actually, I do. I use it for a bloody podcast. Fine. I'll use this big... Oh, that's kind of satisfying. So, paragraph 2. You want to talk about... well, again, you can either have it third or second or first. But I'm going to have it second. So, fears that the Soviets had about the Prague Spring. So you want to talk about how, I don't know how you spell bloody Brezhnev. I'm just going to put Brez. So Brezhnev feared that if these liberal changes were introduced, he was disgusted because it meant, and despite Debek kind of saying, oh, we're not going to leave the Warsaw Pact, he was convinced that they would, and it would influence other Warsaw Pact members to leave. I believe actually one of the things that Debek did, which you could talk about in this paragraph, is I think he signed like a treaty or something with Romania, or some kind of like treaty or support thing, basically giving his support to Romania, which really pissed off Brezhnev, and that was a consequence, well, as a consequence, it led to the Soviets invading. So you could talk about Romania and Debek's support. So obviously Brezhnev was annoyed. he's always bloody annoyed. That's the thing with these bloody leaders. Just rage at everything. But yeah, he was annoyed because he thought they would leave the Warsaw Pact. I'm just going to put it WSP because we're running low on time here. So he thought that they would leave the Warsaw Pact, and as a result, he sent 500,000. I'm going to put 1 million divided by 2. He sent 500,000 troops in to solidify his control. Now, I guess Soviet control does kind of envelope this term as well, which is why I would kind of end the paragraph there and then I'd move on to talking about Soviet control, where you can then talk about the aftermath, how was arrested. A hardline communist was introduced as the leader. And finally, the Brezhnev Doctrine. The Brezhnev Doctrine, which meant that if one country introduced liberal changes in the Warsaw Pact, all the other countries would just wallop it, would go in and revert those changes through force. So that's what I would talk about. Now, the thing that I think Miss was telling us to really focus on, in terms of narrative accounts, was the whole idea of putting this led to, basically focusing on consequences. So if we go through quickly, just a quick fire summary, Debek, consequences, well, we'll start right at the beginning. One consequence of the leader, the previous leader, I can't remember his name, I think it starts with an I or something. No, it's like Natovi or something. It starts with an N. But one consequence of him being in charge was that it led to Debek. One consequence of him was that it led to the Prague Spring. One consequence of that was that it made Brezhnev pissed. One consequence of that was that the tanks, not Soviet tanks, that was the troops got sent in. And one consequence of that is that the Brezhnev Doctrine was introduced, new leader was established. You're basically wanting to roll consequence after consequence. The thing that annoys me about this question is it's 8 marks, and yet, surprisingly, you get about 10 minutes to do it. I really feel like this question should be at least, I don't know, literally 9 marks or something, 3 for each paragraph, or 12 marks. But I guess if you're really writing fast, you can do it, but I don't know. My hand burns after I write for like 10 minutes. But anyways, that is that. That is the history bit done. We did go through on the other stream, which has now since been deleted. We went through 2 consequences of the Soviet invasion of Afghanistan. I talked about how it made the USSR look weak because it took them 9 years to not really do anything, and it also kind of destroyed the reputation of communism. Well, not destroyed, but I guess it heavily damaged it because the fact that a communist country was attacking another communist country, really didn't make any sense. His rationale behind it was really weak. Luke's asking why this. Oh, one of them anti-Italy. It's just permanently loaded. A lot of the IRL streams do that because Streamlabs can be really buggy at times, which is a pain in the ass when I have to end the stream every 5 seconds. I do things like that. So anyways, that was the history section. Now I want to move on to math, but I don't really have a solid past paper or anything, so I'll go look at my math book instead. Here's this is GCSE statistics. I guess we'll do statistics instead. Nah, we'll save that for the last stream. That's combined science. I just have them all in a box because remember my house is currently being packed away. Do I even have a math textbook? I don't think I do. Bugger. I guess we'll have to move right on to chemistry then. Alright. I have the answer book there, so we can go through them. Let me just go find the bloody textbook. Where the hell is it? Did I get one off a teacher? Yes, I must didn't. Yep, there we go. Okay. Here is an exam book. So let's just go. What should we look at? I mean, today we did neutralisation reactions. So I guess we'll go to page 52 and look at them. Okay. Write a name for the substance in table 1 that is an acid. Okay, this is, I think, fine. You have beer, bicarb soda, and milk, and you're given their pHs. You're given 4, 9, and 7. Guys, which one of these is an acid? Well, obviously, it's the one with the lowest number. Remember, on the pH scale, 1 to 14. But what Mr. McCallum said, which I think is important, it is important. If Mr. McCallum says something, it's important, is that the scale is not linear. It actually could go on for ages. You could have alkalis in the 30s. You could have acids -12. All it really means is how strong an acid it is. And remember, acids, the stronger an acid means that it is able to disassociate from the solution. I believe that's the rough term. It's able to disassociate, which means it turns hydrogen into hydrogen ions, positive hydrogen ions. So yeah, obviously the answer there would have been beer because it has a pH of, you get me. Let's have a look at some more. What colour would you expect to see if universal indicator was added to bicarbonate of soda solution? So that is an alkaline. So if I'm not mistaken, red is a strong acid. I think purple is a strong alkali. So probably a blue, would it not be? Because it's quite a weak alkali. Let me go soon. See, again, once I get these streams fully set up and stuff, you guys will be able to kind of follow along with me. But it's taken a while to get everything set up, isn't it? So let's have a look. Blue/blue-green. Alright, yeah. I did that right. That's good. Good to see that I'm getting the 1 mark questions right. Alright, let's keep it going. Which ion is produced by an acid in an aqueous solution? This is literally what I just said, guys. A strong acid means that it can dissociate. It can turn hydrogen atoms into positive hydrogen ions. So the answer there, in an aqueous solution, which is what an acid is, I believe, it is H plus. State the range of a pH scale. Jesus Christ. It's 1 to 14. You know what I mean? 1 there, 7 there, 14 there. But remember, the pH scale is not linear. It could go up to infinite, really. But I think if you had an alkali in the billions, that'd be pretty bad. Now, a good thing to remember about acids and alkalis is that acids are like their own individual category. An alkali is not its own individual category, it's part... Oh, bug out. That's what happens for cleaning my board so fast. No! Let me wipe out with my hands and get them well. So yeah, oh no, there we go. Oh, that's horrible. Okay, there. So acids are part of their own individual category, but alkalines are just a small part of bases. Bases. And yes, based, my first one, the alkaline is based. That is a very humorous meme that you could technically make, because it's true. Alkalines are based. Wipe, wipe, wipe. Okay. I'm gonna go grab my bloody rag. Oh, my good old rag. I'll be back in a sec. I got it. Okay. So, where were we? Acids and bases. Okay. Write the general word equation for a neutralisation reaction between an acid and an alkali. Where's my bloody pen gone? That's right, I walk, okay, there, it's in my pocket. Okay, I'm not honestly, I think it's literally just this. Acid plus alkali, and you get yourself, I'd assume water. What, isn't it water vapor? No, shit. No, it's hydrogen gas and water, I believe. Let me go check that though. I'm not sure. Acid plus oh, it's a salt. That's what you can observe. Guys, don't write down what I just wrote. Salt. Remember that. I guess a good way to picture that is acids and alkalis are salty. But also, think about it this way. If you have like stomach acid problems, I don't know, that's a weird thing to ask kids, isn't it? I don't know, if like your grandparents or someone has stomach acid issues, they likely have alkali, like tablets or tablets with a higher pH in order to neutralise. That's what it's called, remember, neutralisation. And a byproduct of that is water, because think about it this way, you're mixing a strong acid with a strong alkali, and what's right in the middle of a pH scale? 7, aka water. And salt, I guess you could just, I don't know, say when the alkali is salty. I don't know. In terms of hydrogen ions and hydroxide ions, write an ionic equation for neutralisation. Alright. So, you have your acid, which I guess we could put sulfuric acid, SO4. I'm not sure what an alkali would be actually. What could an alkali be? Okay, this person's done it completely different. They have done H OH let me have a look. Now, where the hell is my bloody pen? Now, I believe, I mean, hang on, let me check. Yeah, okay. So, I mean, what our bloody teacher was explaining with this at least, is one of the questions in the exam will ask you to do an ionic equation. Most likely, again, obviously can't predict the exam questions, but I think this is the simplified version of that, like the completely balanced out one. Because if I remember from the worksheet that we did today, it was like a bunch of other shit, like it was like HSO4 or something like that. But what you could actually do is you write the charges and then you can cross out all the ones that are the same, like the same thing. So like if OH is on that side, you can cross it out, for example. So I think that's what he did. In fact, I can go grab my book quickly and show you guys, because it's no use me trying to half explain something. Ended up walking into a fucking wall. Jesus Christ. Oh, my foot's never going to recover from that, is it? So, let me check what we did today. Please say I wrote it down somewhere. Okay, yeah. So this is literally what he did. But again, this is the simplified version. So in your exam, if it says something about the ionic equation for a neutralisation reaction, this is a copy and paste thing. This is what you do. H plus OH minus H2O. If you can remember that, you don't need to do all the other complex shit. Like, cancelling out, getting the ions right, because it's a pain in the ass. You also need to include the state symbols, which for both of these is aqueous, because remember, an acid or an alkali is in an aqueous solution, but the byproduct here is in a liquid, because water is a liquid. Okay, let's actually go do some more questions from this worksheet that we did to the... Oh, here's a good one. It doesn't really, I guess, link with acid reactions, but we're going to do it anyways because I need to remember this as much as you guys. Describe a method to make pure dry crystals of magnesium sulfate from a metal oxide and a dilute acid. So, we have our magnesium and a metal oxide. No, sorry, the reaction is a metal oxide and a dilute acid. So our product is magnesium sulfate, and in order to get that, we need a metal oxide and a dilute acid. What's our metal oxide? Well, it's magnesium oxide. And our dilute acid will be sulfuric. Now, if you didn't get that, it's because magnesium is obviously a metal, and it's asking for a metal oxide. Dilute acid, hydrochloric acid, sulfuric acid, you know what I mean? It's kind of obvious. So, how would we write a step-by-step instruction manual on what to do? And I think didn't the exam questions? Alright, okay. We got a good version of it. Okay. So how do we make pure dry crystals? Well, what I believe is you would get a beaker or something like that. Let me check the max scheme in a second. But you would get a beaker and you would add your sulfuric acid. And you would add your sulfuric acid to the beaker. Now, because you have stated what your dilute acid is, you would literally get a mark for that. And if this is a 6-mark question. So let's put a tally here. 1, 2, 3, 4, 5, 6. Let's see how many marks we get. Next, if I'm not mistaken, you heat it up to increase the rate of reactions. I don't think you even need to specify that, and you get a mark for it. Next, you would add some magnesium, not magnesium, oh yeah, I'm reading this side. You would add some magnesium oxide, and then you would add excess. Now, I'm honestly not sure if the excess step comes before you heat it or not. He kind of rambled through it really quickly. So I'm going to put you add your excess magnesium oxide, because if you add excess, it means all the acid is used up by the end of a reaction, so you get the most amount of crystals. There's some exam questions where it'll actually force you to explain certain steps, so that's a good one to remember, those two. So there you go, number 3. Number 4 here, so once we've added excess, you want to filter it to get rid of that excess. Because let's think about it this way. If I got, I don't know, a bloody cup of boiling water and I added a shit ton of sugar to it, so eventually some of that sugar is just going to sink to the bottom. It won't be able to be, dissolved into the boiling water. And as a result, we need to get rid of that sugar that's, not reacting. So you would filter out the excess. And then if I'm not mistaken, you would evaporate the solution. So getting rid of all of the liquids, all you're left with is like the solid. And then you would leave to crystallize. And finally, the most important bit, it says pure dry crystal, which means you have to either pat it down or I think you can heat it up, something like that, undampen. So what have I put here? I put in a beaker, heat up, make sure you've added excess, until magnesium oxide at the bottom. Filter, evaporate, crystallize. Yeah. So I basically did that right. I would say maybe I accidentally missed like one tiny point, but whatever. That should be 6 marks because I've talked about that. I've talked about heat, filter, evaporate, crystallize, and part. That's literally all the marks I could have possibly got from that. There are some good questions in chemistry that if you can literally think of a copy and paste response, you will get full marks. For example, a question on how the Earth's early atmosphere developed, or like how our current atmosphere developed from the early one, you could talk, there's a copy and paste response. You say that green algae photosynthesizes in order to convert carbon dioxide into oxygen. That's like 2 marks. You talk about how like plankton in the ocean made shells out of the carbon dioxide that dissolved into the water, and how when they died, the shells sank to the bottom, sediment covered it, carbon locking the carbon. You could talk about, what was the other point? I guess that's literally it. I guess that literally would be like 6 marks in an exam. Wrong, water can be solid. I mean, I suppose, but just on its own, as a byproduct of the neutralisation reaction, it wouldn't be ice. I think that would be impossible, but I mean, I don't know if you did it in the right conditions, who knows. Anyways, so that is kind of maybe all I'll do with chemistry. So, what are the important things to take away from this lesson? And no matter what set you're in, remember these. For crystallization, step by step, the acid and alkaline equals water. You want to remember the equation for that, which, if I'm not mistaken, is H plus OH minus equals H2O. Let me just check if I've done that right. Yep, I did that right. That is the reaction. H plus, so that's hydrogen with a positive ion, plus OH minus equals H2O. And finally, I guess one more thing I remember is just kind of the whole pH scale as a whole and universal indicator. You want to talk about how if it's a strong acid, it would be red. If it's a water, if it's like a neutral, it would be green, and it would be purple. Or I guess that should be green/blue. And if it's purple, it's a strong alkali. So there you go, guys. I hope you took something away from that chemistry section. Because seriously, chemistry sucks in terms of it is tough to remember so many things. If I even helped you remember one thing there, give this video a like, or screen record a part of it, maybe add it to your revision notes, something like that. Because chemistry, it's a good GCSE to have. You know, chemistry is a rapidly evolving sector of the world. If you can get a good grade in chemistry, even if you don't take it in A-level, which I'm probably not going to, it'll still look good, you know what I mean? I know people taking double science probably won't even, like, get a GCSE for chemistry, or will they? I think they get 2. I don't know. If you're in double, let me know how that grading system works. I'm really not sure about. Check. But yeah, and also on a real note, I know that a lot of people don't like these streams that I'm doing. I'm just gonna take out the biology book. We'll do some biology. I know a lot of people probably don't enjoy these streams because I know that I'm obviously JMC Gaming. But guys, on a severe note, shut up. Because really, we have 20 days left till exams, and I am not only wasting my own time here to help you guys, but you know, that is time that I could be spending doing proper revision, and I'm only really scraping the surface here. If I get into really high level content and I end up getting confused, I might confuse you guys, and I don't want that to happen. So I'm doing my absolute best here to help you guys as well as trying to help myself. So please, if you know anyone who might find these streams helpful, I don't know, share them it. I don't know, do what you really want, but just understand that. All right, guys. Okay. So. Let's do. What should we do in terms of... Okay, let's maybe do the blood vessels, because Mr. Hooper explained this to us. Which one of these is an artery? I don't know if you guys can see that, but you have one kind of thick one, you have one kind of thinner one, and then you have a very thin one. I believe the answer is A, because arteries are meant to be thick. They have the thickest blood vessel, I believe, because they carry blood out of whatever. They carry the oxygenated blood. The blood in the arteries flows under high pressure, exactly what I was talking about. Arteries are thick, just like I put there, they are thick because it flows under high pressure. So one adaptation of the artery there is that they are thick so that, doesn't happen, so that the blood can keep on flowing without, bursting the blood vessel. I guess another one would be that they are narrow, so that it limits the amount of blood, so that it doesn't, cause such high pressures. I'm not sure if that would be one, actually. Let me go check. Again, Mr. Hooper is not the best at biology, I'll be honest with you, and as a result of that, I'm kind of screwed if it does come to the GCSEs. But I believe I got that right. Page 27. Let's see. The walls of the arteries contain thick layers of muscle to make them strong. Elastic fibers allow them to stretch and spring back. Okay, so they went into proper detail there, which I didn't. I only kind of loosely explained it. But yeah, the arteries, if we look, I guess... But imagine that's a thick layer of muscle, and that is to, stop such high pressures, because think about it, if something is in such a high pressure, it's going to burst. So it needs to be a thick, muscly layer so that it can't do that. And what was the other one? The other one was elastic fibers to let them stretch. So actually the opposite of what I said before. They have elastic fibers in them, which I'm guessing is kind of this thing. They have elastic fibers so that they can kind of conform. Their shape kind of changes depending on the level of pressure. So there you go. One thing that you didn't learn there already. We're going to try and do 5 things that we didn't learn. One is that arteries have muscle to keep them strong, and they also have elastic fibers. So if you get that question in your exam, thank Germ C. Next, name the type of blood vessel that has valves. I already checked the answer for this by mistake, veins. But I guess the best way to remember that, valves, veins, they both start with V. Why does the blood vessel named in 1.3 have valves? So why do veins have valves? To stop backflow. I believe that is the right answer. Let me just check. But I think I got that right. Yep, to prevent backflow, to keep the blood flowing backwards. Imagine it like a tunnel, for example. Imagine the blood vessels like goofy ass, my Minecraft Civil War bloody tunnels that I dug to get into Harry's base. Imagine like the heart is Harry's base, where I believe he killed his dog by accident. And imagine this is my kind of that whole base where it was kind of half and half. But anyways, I dug it so that it would go into the water like so, and the water would go down and it would kind of slowly go there. But imagine what would happen if the water just kind of went the other way. It just went this way instead, and it rushed out, and I don't know, it made a big water explosion. That would tell Harry where I am, but also that would obviously lead to death if, you know, the blood is going back over. Bad, isn't it? So, in other words, the blood vessels are designed to have these little valves, which I'm not sure what they look like. I think they're like the things in a heart where it's a bit like this. So it's like you have like the blood goes in and then it's this very tight passage, so that the blood requires a lot more pressure to get outwards than it does to go in. So valves are to prevent backflow. Now I already knew that, but in case you guys didn't, write that one down. Valves stop backflow, and veins are what contain valves. What is the next question here? Oh, that's chemistry. I guess, should we skip over blood vessels? Because, I don't know, no one's really said anything here. Okay. Explain why the walls of capillaries are only one cell thick. Refer to their functions. Okay. Capillaries are very small, and just like the exam question just asked, they are one cell thick. So they are tiny, but that also means there can be a large amount of them in a given area. So I guess one reason why they're one cell thick is to have a large surface area to increase the amount of blood. But if I'm not mistaken, capillaries are for ions or cells. They deliver ions to the right area, and for that logic, I would assume that it's to prevent blood. Capillaries carry. Oh, they do carry blood. Oh, okay, yeah, I got that the wrong way around. They carry blood to cells. So they directly carry it to cells, not organs, unlike the veins and arteries. So remember that one. Having thin walls increases the rate at which substances can diffuse. Okay. I get it. So imagine these are some lovely little capillaries going flooba-dooba-doop. I don't know why they're so like tentacly, but they carry blood and they are going near cells. Bunch of these cells here. I don't know what cell is, but the GMC cell. So basically, diffusion is where something goes from a high concentration gradient to a low. And think about it this way, they are one cell thick. So only one cell at a time is really going to be through here. So there's not too many cells. There's still thousands of millions maybe, but there's not too many that are outside. So think about it this way. The cells, it's one cell thick, so, you know, that means that there are more cells on the outside of a capillary than the inside. And as a result of that, the cells are going to diffuse. And also, the fact that they are one cell thick, again, makes it easier for diffusion. They're small size. So there you go. That is literally it. The reason they are one cell thick is so that they can carry blood another thing, I guess, is that this goes back and forth, because if there aren't that many cells, or maybe there aren't that many ions, the ions are then taken into a blood vessel. So I think it's actually the ions in the blood. It's the ions that are in the blood that are being diffused, not blood itself, because that wouldn't really make sense. So ions are going either into the large concentration gradient, the low concentration gradient, or they're going into... Alright. So we probably spent 10 minutes on history, 20 minutes in chemistry, 10 minutes in biology. Hello. on another note, we do have a build battle later. This stream I'm gonna do for an hour. I'm gonna do it an hour every day. So 15 minutes and then I will. Gonna turn off chat so that doesn't get in the way of my thirst. Okay. Let's go do some more interesting biology here. Let's do okay, controlling body temperature. I'm skipping a lot of the topics that I'm not confident with, purely because if I'm doing these explaining things, you guys are going to get confused as much as I am, and we won't be able to help each other. If I do things that I kind of know, it means that I can learn with you guys. So, controlling body temperature. Name the organ of the body where the thermoregulatory center is located. Shit. I believe that is the brain? No, I think it's one of the glands, actually. Shit, hang on. Let me check this. I need to know now. I gotta know this. Yes, it's the brain. Okay. I was overthinking it by assuming it was a gland. The thermoregulatory center contains receptors. What are these receptors used to monitor? I'm gonna assume body temperature because thermoregulatory, which means it regulates your body temperature. I assume it's body temperature. Temperature of the blood. Okay, not body, blood. That is important. That is important. I guess if we assume that this is a Donnie's arm, I don't know, this is a horrendous... Oh, it looks heinous. Okay. Let's just assume that his hand... Oh, no, I'm not even going to try drawing that. Let's just assume that this is part of someone's hand, right? Think about it. If warm touches your skin, it's going to then... some of that heat is going to get in to your blood. And if your blood is kind of warm, your body's going to make it a little colder so you don't die. Briefly outline how the thermoregulatory center receives information about the temperature of the body. I'm not sure. The skin contains temperature receptors. These send nervous impulses to... Okay. So the brain... Let's just... I don't know. This is your brain. It contains thermoregulatory receptors. So, like, I don't know. I'm going to draw a square in it, even though that's obviously not how it works. And I guess those will be able to monitor the temperature of your body to a sense. So what... Oh, okay. They send the impulses to the sensor. So, basically, if we assume that this is our skin here, what's going to happen is our blood here, and blood. What happens is our skin is going to send impulses to our brain to tell us, well, to tell the brain our current temperature. So if it's fecking freezing, our skin is going to send impulses to notify our brain of that, so that it can respond in time. The body has several ways to regulate this temperature. How these responses bring about a change in body temperature if the temperature becomes too high. Okay, so if the temperature is high, what happens? I actually sit down, pause the stream, think about it. What happens when your brain... What happens when you get too warm? You start to sweat. You don't do the things that you would do if you're cold, if that makes sense. So when you're cold, your body needs to obviously get heat. So when it's cold, and we'll do hot versus cold. Well, when you're cold, you shiver. Your I guess muscles shake. What's a better word for that? Your muscles vibrate. Not really a good word. There's a word for it, and I'm missing it. What's the word? literally shivering. Okay. I thought there would be like a big scientific term for that, like Vlukadogaskada. No, literally just shaking. So when you're cold, your body shakes, which, I mean, think about it. When you shake, it's movement which gets the blood flowing. It increases heat, and also when you're cold, your blood vessels, I believe they contract, not dilate. Nope. Oh yeah. Okay. Your blood contracts, your blood vessels contract. So imagine this is like your arm. This is a bloody blood vessel. Okay. So blood takes in heat, but it also loses heat. So if you're sweating, your blood vessels are going to widen. They are going to dilate so that more blood can be flowing, so that more heat can get out. On the contrary, if you're shivering, if you're absolutely freezing, your blood vessel is going to shrink. It's going to constrict. And what that basically does is less blood is flowing, which means less heat is lost. I think that's called vasoconstriction. So it's either vasoconstriction or what the other word? Bollocks. Why can't I remember it? Vasodilation. Bloody hell. Okay. So you can tell I'm kind of getting a bit tired now because I'm making some mistakes here. But I think that's a good place to end it. Okay. Well, let's do a quick recap of everything that we've done today. Number one, how do you make pure dry crystals? If you're sat at home now, do this along with me. Number one, you get your acid, whatever it is, sulfuric acid. You pour some into a beaker. Number two, you heat that bitch up. Number three, you get your solution. You get your solid, you get your metal oxide, and you add that in, and then you add excess. Keep adding excess until it stops reacting altogether, and when that happens, you filter out the excess, you evaporate it, and then you leave it to crystallize. And if it's a pure dry, remember, pat it down. Give it a nice little pat. Okay, what is the reaction? Not word equation. What is the actual equation for an acid and an alkali, a neutralisation reaction? If you guys don't know this, I'll be disappointed. It's H plus H minus equals H2. I believe, anyways. But please, okay, yeah. You know, I just realised you can, a little cheat. Think about it. A little cheat here. Let's say, in the exam, it says neutralisation reaction. And you're like, what the fuck? I don't know. Think about it. Neutralisation makes water. That's all you need to know. Because watch. Seriously. H2O. Okay. Watch. That little 2 symbol means that there are 2 hydrogens. You put 1 hydrogen there, 1 hydrogen there. Or, you put there. Then, you literally just fill out the rest. And then you do plus, minus. And that is it. That is the whole thing. If you seriously don't know anything, just remember neutralisation, one of the byproducts of that is water. Salt, on the other hand, I think you'd say that for the word equation, but one of the products of neutralisation, water. There you go. And of course, you put the symbols of aqueous liquid. Guys, seriously, if you don't know that, revise it, because I didn't know that, and now I do. And on the exam, it's worth 1 mark here. No, it's not. It's worth 2 marks. But, guys, you can answer a bunch of sub-questions now that you know that. Okay, look. Soluble salts are formed by reacting metal oxides with acids. Give one other type of substance that can react with an acid to form a salt. Okay, so we know that metal oxide forms with acid to form a salt. What else could we use to react? Well, it says here, sorry, I'm explaining this pretty badly. Give one other type of substance that can react with an acid to form a salt. Acid and alkali, neutralisation reaction. That's literally what you put. And because of that, you've just gotten another mark. 3 out of 200 for your total GCSE, just by literally watching this GMC Arts video right there. By watching this video, you have gained plus 1.5% of your GCSE. But, no you haven't. You've gained more than that. Because I just talked about the crystallisation reaction, which is another 6 marks. Guys, you could almost get 5% of your GCSE just by remembering this simple information. Okay. Let me do one other thing. So we've done crystallisation, and I'm going to make a note, guys. I'm going to honestly pour my heart and soul into these revision contents so that you guys can understand it as much as I can. Because honestly, this shit is whack, you know? Having to revise a bunch of shit every single minute of every day is painstaking. I understand that, guys, and I know that most of you would rather sit and go play some games. I would rather do that, but I am putting in some serious effort here to help you guys. And because of that, I'm going to make a little key here of what we've done, and every stream I will test you guys on it, so keep on watching. Okay, I'm going to put crystallisation, but we may come back to that. Neutralisation. So these are the topics that we've done. Blood vessels. Those are the topics that I guess we've smashed, right? I've now explained to you neutralisation. I've now explained to you crystallisation, the whole concept of making it. Blood vessels, we quickly went through. Now, if you guys need me to go through anything tomorrow, let me know now. I see there's 2 viewers. Let me know. If you want me to go through anything science, math, English, just remember, I'm not a god. I'm not Isaac. I don't know everything, but I do know some stuff. You know, so I assume with that logic, if you guys need any help, or if you guys want to help me, like if you saw that I made a mistake, pop it in the comments. It'll benefit all of us. Remember, I'm doing one of these every day, probably from 6 till 7, or maybe 6:30 till 7:30. God damn, I wish it were that easy, man. I wish, bloody hell. Honestly, on a serious note, please let me know. Do you guys feel confident for your exams? Because I know that people like Alex, since bloody year 7, he's been on about, you know, wanting to smash his GCSEs, doing really well. I know there's some people who have been dreading it since year 6, you know. I know me personally, I don't feel too confident. I'm a little bit in the middle, right? I know some stuff really well. I don't know other stuff well at all. Biology, I'm taking it in A-level, but I think I'm fucked because Mr. Hooper hasn't explained shit to us. If I had a Mr. McAdam for biology, I would get the grade 9s the whole time. But no, man, I don't have the best teacher, and for that reason, I feel a bit shaky with that. Everything else, I think I'm fine in. I think math should be alright. You know, I do alright in that. English language will be okay. English literature might be a bit tough because remembering quotes is a pain. So yeah. You don't feel confident? God damn. I mean, dude, what specifically, if you don't mind me asking, like, what specifically don't you do well at? Like, is it like, do you know the content, you just don't do well in exams? Do you, like, just not enjoy any of it? Like, do you enjoy it, just don't understand? Like, because I feel like when people don't do particularly well in exams or aren't looking forward to it, there's not really a core reason. Math. Oh, damn. Okay. Well, dude, we do go. I will go through maybe tomorrow because the thing is, I had a little revision timetable set up. Today was going to be math day. Tomorrow will be English day. Wednesday would be science day, which it still will be. And Thursday will be history day. And then Friday, I'll do an hour and a half stream where we talk about a bunch of different subjects. But I think I'm just going to do a bit of each every day. So let's say tomorrow I have like English, math. No, I don't. English, history, science, something like that. I'll pick the most important things that I learned or the things I don't understand much about, and I'll do them. Anyways, I hope you guys learned something. Stream of a PS game where your camera is on and we both do the remote. Oh, I just flipped my camera around. That is my, what is that, my coat? I don't know. I don't even do the 10 dude, no, you gotta ask your teacher, bro. You gotta get help, man. Get away with it. I just fit, dude. Nah, man. I don't even do the stream a PlayStation game where your camera is on and we both do the revise. Dude, I prefer doing it this way. A, because access to my whiteboard right here. It's fun. I can see the chat. And also, that PlayStation game has an annoying pop-up here. And also, the PlayStation camera's dark. Audio plays, so you guys will be listening to some dumbass background track. I can play music in the background if you guys really want. I could have some bloody Ezra Collective playing. Because that's some bloody good jazz. But yeah, how do I get there then? How do I get there? What do you mean by that? How do I get there then? Well, what do you mean? Like the what do you wanna? Oh, you mean like in the stream? I don't know what you're on about, man. Do you mean like how do you remember this stuff like I do, or what do you mean? Because I mean, dude, seriously, I know that obviously you much prefer if I did an hour, 2 hour stream on bloody the Forest or Minecraft, or we did the build battle. I will be on tonight, by the way. Don't think I'm gonna abandon gaming just because of GCSEs. I'll do a bit each day if I can. But dude, seriously, if you have best shit to do, and I'm live doing one of these streams, maybe just grab like a notebook and just write 1 or 2 things down that I put, like, you know, how I just did there, the crystallization, step by step, the neutralisation reaction, what blood vessels are, maybe even when I talked about like the heart, valves, veins, like just maybe write 1 or 2 things. Here's something, while we're on the topic of revision, how do you like revise? do you like, I don't know, because what I find to be helpful is I do the past papers, but I find that they can be quite annoying at times. If you're doing past papers, I feel like you need to know the stuff well to do well. If you don't know shit, all you're doing is stressing over an exam paper, looking at the answers, and then going, oh, well, I didn't know that anyways. If you're doing exam questions and you're struggling with those, maybe do flashcards or something like that. I have a big deck of flashcards where I literally I'll just quickly show you. You won't believe this, right? Look at this shit. This is my revision folder. It is heavy as shit, and you got literally every topic here, like English literature, math. These are all the past papers. That's literally just for math. You got English books, but in some of these, and I'm not sure whereabouts they are. Let me go have a look. In some of these, I have a big pile of flashcards where, like here, look at this. You got the chemistry folder. No, I make them myself. I have a bunch of cards. If you want, I could give you some. But I think you could ask your teachers and they might have them. But does this one even have any in? It might be in the middle. Did I put them in the other folder? Huh, where the hell did they go? Hang on a second, my bloody flashcards have gone missing. I was trying to bloody show you and they've just kind of vanished. Oh, there we go. Okay, so look. So no, I make them myself. No, I'm okay. I mean, dude, just ask Miss Keeler or something, bloody form tutor. I'm sure she could find an empty pack for you. But literally, I just make them myself. I have these tiny envelopes. Each one, for example, this is chemistry. Each one's a chemistry theme. For example, topic number 4, chemical changes. We pull out these, and then we look. What is an acid, and how can they be weak and strong? And then I obviously just look at the back. Acid is a substance which can dissociate to give hydrogen plus ions. Strong acids fully dissociate in water. Weak acids partially dissociate in water. So literally what I'm doing, I put a question on the front, the answer on the back. And then what I'm going to probably do soon is I will just put them in different categories. So like if I'm struggling with one question in particular, I'll pop it like in here. I'll put them like, I'll make like good, okay, bad. Any that are in the bad tier, I'll revise more. Grade 4 is okay, isn't it? Not to say. Okay, well, dude, grade 4. Think about it this way, right? If I don't mean to. In fact, I'm gonna put my light on so you guys can actually see the board because it's getting dark. But right. Thank you. Okay, so grade 4 is okay. So think about it this way. Bro. So grade 1, 2, and 3 is a fail. Grade 4 is a pass. So seriously, if you were considering, so while I'm doing this here, what grade, like what are you doing for sixth form? Are you doing sixth form? Anyways, grade 5 and 6 are strong passes. Strong pass. So these are all fail. This is a pass. Grade 7 and 8 are like, I don't know, omega pass. Seriously, I would say anything above a grade 6, don't sweat it. If you're getting above a grade 6, you're doing obviously well. You don't need to do a bunch of bad shit. And then grade 9, I'm just going to write piss off. If you're getting grade 9s, congratulations. But seriously, you don't need a grade 9. Teachers will be like, guys, shoot for grade 9s. But look, you don't need a grade 9 to do anything. 4 is fine. Sure, it might not be like the best, but so bloody what? If you're able to consistently get a grade 4, even a 5, well done. If you can get that in the exam, you've passed. If you can get grade 6s and 7s, bloody well done. That's great as well. That's, you know, I don't know, maybe it'll look better on your resume, I don't know. If you're getting grade 8s and 9s, you obviously understand the subject really well, and, you know, at that point, don't sweat it, but, like, I could get a 6 in English, but, like, a 4 or 3 in math. I mean, dude, grade 6 in English is great. Like, seriously. Again, like, seriously. that'd look good on your CV, and at the end of the day, that's a strong pass, you know. What is it, like a 6C, a 6B, a 6A, 3B? Like, what are your kind of grades? Because you're saying a 3 to 4, which is kind of in between here, but you have to remember with foundation at least, the first half of a paper, and this goes for our set as well, the first half of a paper, if you can get almost everything right in that first half, you can literally get, I think, a grade 7. So all you technically need to do is get half of the first half right, then half of the second half right, and you'll be getting a 6. So I would revise like relatively simple things so that you can get a foundation. Like, I'm not on about the set, like the actual rock solid bottom of the... I would focus on the basics, really. Like, what is it in particular with math that you struggle with? Is it the more advanced, higher stuff? Or is it just kind of, you'll make kind of a couple simple mistakes now and again that will slip you up? The higher stuff, I mean, Miss Glenn does after schools, but I'm not sure if they'd really be for your set or not, because we do a bunch of complex shit in those, like completing the square functions and stuff, factorization. But I think one of the other math teachers does an after school, and I know you might not like after schools, but I mean, maybe if you do one, and maybe you could ask the teacher beforehand, say, could you go through blank, you know, maybe they'll go through it. Plus, I forget, alright, so it's like the method that you don't, like, fully get. So, like, I don't know, complete the square, like, the method for that, you'd think. See, that can be a pain. Often the method is the bit where, like, you get the most marks too, isn't it? You know, if you just pop the answer right down, you get, like, a mark. If you get the method. But I think, in math at least, you could do some of the method and still get a mark. So if I was to complete the square, I'm not going to, like, narrate this through. I'll just give a hypothetical example here. Let's say I made a mistake here. For example, I didn't put the minus 4 squared. I probably would still get a mark at least for that. So long as you can half do the methods, or kind of can visualize how it would be, I would say, now that's kind of what you gotta kind of focus on. Or let's say here, minus 4 squared, minus 3. Let's say that I did that as minus 16, minus 3. Let's say that I did that as minus 13. I did the wrong equation. I would still probably get a mark, maybe even 2. So I think that's what you got to focus on then, man, is trying to at least visualize the method. Because you're saying it's like the higher stuff, I suppose, like algebra stuff, maybe geometry, you know, the whole thing of like x plus 2 plus b, and you have to like work what it is or whatever, and like find a shaded area, things like that. There is no particular method for any one math question. A lot of them are combinations of other methods. So if you can, that's what I would say. If you can nail down the basics, it would probably help you a lot. Because I mean, think about it, like, the even most difficult algebra questions can just be adding and subtracting. Like, literally. Like, if we did, or multiplying, if we did 6x plus 2, and we did 2 plus x, all that really is there is 12x. It's literally just multiplying 6x squared, 4, 2x, and then it's adding 14x, 4, 6. Like, so that's what I would focus on, bro. That's what I would focus on. Trying to nail down the absolute basics. Because yeah, math sucks, seriously. I'm doing core math because math itself, I would hate to do an A level in that. I think core math is the perfect balance of like interesting, useful, and math. But if you're not planning on taking math, I wouldn't worry so much about it. Just so long as you can get a 4, and it's quite literally it. Chemical changes. Very quickly, I'm gonna do. I'll stay on for another 15 minutes if you guys want to ask anything. I'm just gonna go do some quick questions here. Just for like. Just a quick little overview of what we've done today. So, also be sure. Good. Okay. So, what I was saying is, will you make a new channel for reaction video? But the second channel is kind of reaction videos. Remember, JMC Arts is on break right now. JMC Arts will be returning full blast after GCSEs. We'll be doing a bunch of videos. I'll be really looking forward to doing videos like Anthony Ghost Hunter returns. That'll be one of them. I'm bringing back Anthony Ghost Hunter, the character. He'll be appearing. That'll be fun. There's going to be a bunch of new kind of videos and stuff like that coming out on JMC Arts. JMC Streams, now that I don't stream on it, I've changed it to Joseph M, and that'll be a reaction channel, or just a piss off channel. I'll upload stuff there, like maybe bloopers for videos, just anything. Second channel, generic content. Whatever I can fathom, I'll do. So I don't know, if maybe I'll do a monthly reacting to subscriber videos, I could do commentary videos. Anything that the second channel, anything that the main channel can't really fit in. Or you could make a podcast channel. I mean, could you? I mean, dude, you're sharing your voice now on streams. I know, obviously, like the streams are listed and stuff, but I mean, that's a really good step towards, like, you know, if you do want to do a channel together or something, or a podcast. I mean, I know you keep suggesting like doing text to speech and stuff, but that would be a pain in the ass to not only edit but to like script and everything. If we could do like some like a proper project together or something, that would be sick. Okay, I'm done kind of tidying it. Is there anything else you guys want to go through while I'm here? Because I need to kind of drill some stuff into my head too. This question is about metals and reactivity series. Which two statements are properties of most transition metals? Remember this one. Transition metals form ions with different charges and they have high melting points. Brilliant way to remember that is iron. Iron 2, iron 3. And it's literally it. Should I start a streaming channel? Yeah, make a new channel. Up to you, dude. I would say that's a good thing. Make a new channel. Just obviously just remember, I probably won't be doing too many. I probably won't be watching. If you do stream, I might not be able to watch all of them because I'm going to be not only doing my own streams but revising a lot. I probably won't come in from home most days till 5 because I'll be doing after schools and shit. So, yeah, maybe I mean I could probably on the weekends watch them, but I will try my best, man. I will try my best to watch. Because yeah, I'm bloody keeping my own thing. Wholly over account. What? Oh no, what have you found? Okay. Let me just Oh, here was a good question. 5x equals 10x plus 4. Okay. He deleted it. What? Todd Murgatroyd? Or what are you on about, bro? Anyways, quickly, for those who are still watching, this would be a complete the square question, but look at how weird this is. 5x squared equals 10x plus 30. It doesn't make any sense. It does. Watch. Divide by 5. So you get x squared equals 2x plus 0.8. Then you would minus them. X squared minus 2x minus 0.8 equals 0. You just minus them both off so that the total is 0. And from there you would complete the square. Watch. X minus 1 squared minus 0.8 squared equals 0. And I'm not going to do the rest because I don't have a calculator. Oh yeah, I do. 0.8 times 0.8 gets me... Give me the answer. 0.64. 0.64. Oh! No, hang on guys. I'm so sorry. I've done this totally wrong. Jesus. Jesus. Minus 1 squared gives you minus 1. Minus 1 minus 0.8 would be minus 1.8 if I'm not mistaken. Yeah, minus 1.8 equals 0. X minus 1 squared, which will get me 1.8 equals x minus 1 squared. Square root of 1.8. I'm solving. I'm getting the solutions here. X minus 1. 1 plus the square root of 1.8, which would get me... Give me the jackpot. That would get me 2.3, which I believe was the answer. And come on. 0. Minus 0.3 for... I need to check if that's right. Find a resin. Huh. Interesting. So, I'm not sure if that's right. I'd have to actually Google the mark scheme. I may have done this in the wrong order, you know. Maybe you had to minus it first. I'm not sure. You know what? I will go check that. And I will end the stream now, guys. I'll leave... In fact, I'll be right back, actually. If I got the right answer... Oh, that's my... If I got the right answer, I will let you know. Okay. Hello. So I got it right. That was in fact the right solution there. Anyways, it's late now. I'm gonna go do some other stuff. Thank you for watching today's video. Remember, I've wrote the topics that we did on the board: crystallization, neutralization, and we also did a brief discussion about blood vessels. Remember, veins, valves, arteries have thick muscle layers and elastic fibers, not electrostatic fibers, elastic fibers, so that they can change shape depending. And remember, capillaries is obviously for ions, things like that. So anyways, that's all I'm doing for today's video. Hope you guys enjoyed. That was quite a lot of fun doing the first ever proper revision stream. I'll be back tomorrow where it'll probably be a lot of English literature for Lord of the Flies. Probably the character of Jack, and also I'll probably be doing some more maybe science stuff, maybe biology. So if you guys are interested in that, be sure to watch. If you're not interested, don't watch. Just remember that these streams are taking up a lot of my time, so trying to even just remember one thing from them would really help you as much as it would help me. Goodbye.